Hey everyone, welcome. Today, we're going to pull back the curtain on the digital world to look at the one thing that makes all our favorite apps and websites possible: software architecture. It really is the secret sauce, the master plan, and by the end of this, I promise you're going to see it everywhere. So let's dive in. I mean, have you ever really thought about it? You tap a button on your phone, and this whole incredibly complex chain of events just kicks off, perfectly connecting you, a restaurant, and a delivery driver all in real time. How on earth does a system like that stay fast, secure, and reliable, especially when they're adding new features constantly? Well, the answer isn't magic, that's for sure. It's all about the blueprint.
Yep, that's it exactly. Just like you would never, ever build a skyscraper without a super detailed blueprint, you can't build complex software without one either. And this blueprint, well, that's its architecture. It's what separates a tough, successful system from what is basically a digital house of cards ready to tumble at any moment.
All right, so here's our game plan. We're going to break down what this invisible blueprint actually is. We'll talk about how it's different from design, a common mix-up. Then we'll get into its core building blocks. We'll cover why it's so critically important. And finally, how it gets software ready for the one thing that's always guaranteed: change.
Okay, so let's start with the big idea itself. What exactly is this invisible blueprint we keep talking about? So, the official definition here is a bit of a mouthful, but it's packed with all the right clues. The words you want to zoom in on are fundamental organization, components, and relationships. Really, it's not about the nitty-gritty code. It's about the high-level structure. How the major pieces of the puzzle are arranged and how they all talk to each other. And that brings us to a place where a lot of people get tripped up. Folks tend to use the words architecture and design like they're the same thing, but they are worlds apart. Let's clear this up once and for all. I love this comparison because it just makes everything click. See, architecture is like the city plan. It decides where the major highways, the bridges, and the different neighborhoods are going to go. It's all about the what. What are the major parts of our system? Design, on the other hand, is the floor plan for one single building in that city. It figures out the layout of the rooms, where the pipes go, what kind of windows to use. It's all about the how. How will this one specific piece actually work?
Okay, so if architecture is this big picture city plan, what's it actually made of? Well, it turns out you can pretty much boil any software architecture down to just 3 core building blocks:
Components, relationships, and constraints. Yep, that's the whole shebang. You can think of it as the nouns, the verbs, and the laws of your system. So let's break each one down, and we'll stick with our food delivery app example to make it super clear.
All right, first up, components. These are the main chunks of the system, the parts that do all the heavy lifting. So in our app, you've got the thing you use on your phone. That's the user app. Then there's the system the restaurant uses to see your order, the restaurant portal. And working behind the scenes, you have a database holding all the info. Each one of those is a component. Next up, relationships. This is all about how those components connect and chat with each other. Because let's be real, a component is pretty useless all by itself. So when you hit place order, your user app has to send that info to the restaurant portal. That connection, that line of communication, that's a relationship. And finally, we have constraints. These are the hard and fast rules, the non-negotiables that govern the entire system. A perfect example is a performance rule. The architecture might demand that the system must confirm an order within 2 seconds, no exceptions. That one rule, that constraint, shapes every single decision about how the components and their relationships get built.
Okay, so now we know what it is, but so what? Why should we care so much? Well, because good architecture isn't just about a neat and tidy diagram. It has a huge real-world impact on 2 things: the quality of the software itself and the people who have to build and maintain it.
And this is absolutely crucial. Qualities like speed and security, they don't just happen by accident. You can't just sprinkle them on like fairy dust at the end. No, they have to be designed and built into the very foundation of the system, the architecture. Let's talk about performance. You want a fast app, right? Of course you do. Well, your architecture has to be smart about how data moves around. It's got to be designed from day one to prevent bottlenecks, making sure information flows smoothly instead of getting stuck in some kind of digital traffic jam. Or what about security? A good architecture acts like a bouncer at an exclusive club. It has a list, and it defines very clear rules about which components are allowed to talk to each other. By strictly controlling that communication, it creates secure zones and protects all the sensitive stuff, like your credit card info, from anyone who shouldn't see it. And oh man, this one is a biggie, especially for the long-term health of any project: modifiability.
A well-architected system is like a well-organized toolbox. It separates different jobs into different components. What that means is you can update one part, say the payment system, without worrying that you're going to accidentally break something totally unrelated, like the driver's GPS track. But it's not just about the tech. It's also about people. The architecture becomes this common language for literally everyone involved. The project manager, the coder, the designer, everyone can point to the same plan to understand how things are supposed to work. It lets big teams work on different pieces at the same time without stepping on each other's toes, all because they're building from the same blueprint.
All right, let's bring it home with our last big idea. Because here's the truth, no piece of software is ever truly finished. The world changes, users want new features, and the architecture has to be ready to adapt without falling apart.
See, a good architecture actually anticipates change by putting it into different buckets. A local change is simple stuff, like changing the color of a button. It only affects one little component. A non-local change is a bit more involved. Maybe you're updating a tax calculation that has to touch both the user app and the restaurant system. But an architectural change? Whoa, that's a massive shift. That's changing the blueprint itself.
And this is really the whole point. A great architecture makes most updates feel like fixing a leaky faucet. Simple, contained, no big deal. It's designed specifically to avoid that nightmare scenario where one tiny change forces you to basically move the foundation of the house. Because that is always costly, incredibly risky, and just slow.
So what's the big takeaway here? Software architecture isn't some nerdy, abstract thing just for engineers. It's the invisible skeleton that gives structure, strength, and flexibility to the digital tools we rely on every single day. So the next time you order food or book a ride or stream a movie, just for a second, try to look past the screen and appreciate that invisible blueprint, the thousands of smart decisions holding the whole thing together.